Hello everyone. Today we are going to discuss about the bond parameters of the aliphatic hydrocarbons like alkanes, alkenes and alkyne systems. So first of all, hybridization. So what is the hybridization of alkane systems? Remember that the hybridization of all the carbons in the alkane is sp3 hybridization. Now coming to the alkene system, the hybridization of double bonded carbon atom is always sp2 hybridization. Now coming to the alkyne system, the hybridization of triple bonded carbon atom is always sp hybridization. Now geometry. So whenever sp3 hybridization comes, the geometry taken by such a molecule is always tetrahedral. So the tetrahedral is simply written as TD. Now coming to alkene systems, the geometry for sp2 hybridization is always trigonal planar structure. Trigonal planar. The geometry for alkyne system is linear. What is the bond order for alkanes? Now coming to the bond order, all the carbons must be single bonds. All the carbon-carbon bonds must be single. Now, alkenes. So, example I am taking here, C double bond C. At least a minimum one double bond should be there. A minimum of one double bond is required. So the bond order here is 2. Here the bond order is 1. Now the bond order for alkyne system is at least there should be a minimum of one double bond must be there. Therefore, the bond order for alkynes is 3. So, the alkynes are, simplest alkyne is ethine. So, it should have a triple bond in it. Now, coming to the bond angle. So, whenever alkanes get tetrahedral structure, the bond angle is 109.5 degrees. So, to be precise, it is actually 109.47 degrees. So what is the bond angle for alkenes? The bond angle in alkenes is generally given as 121.5 degrees. What is the bond angle in alkynes? It is 180 degrees. So all these things are based on the geometry of the molecule. Now what is the bond length in alkanes? The bond length in alkanes is 154 picometers. So 1 picometer is actually equals to 10 power minus 12 meters. So 154 picometers can also be written as 1.54 Armstrongs. 1.54 Armstrongs. Now what is the bond length of alkenes? It is 132 picometers or 1.32 Armstrongs. So why are we getting this? It is nothing but 1 Armstrong is equals to 10 power minus 10 meters. So how can I write this 1 picometer? I can write it as 10 power minus 2 into 10 power minus 10 meters. So we know that 10 power minus 10 meters is nothing but 1 Armstrongs. So I can write it as 0.01 Armstrongs. So 1 picometer is nothing but 0.01 Armstrongs. Now coming to the bond length of alkyne systems, the bond length here is 120 picometers or 1.20 Armstrongs. Now what is the bond strength? Bond strength is nothing but the energy required to break the bond. So bond strength of alkane system is 356 kilojoules per mole. So the bond strength for alkene system is 636 kilojoules per mole, and for alkyne systems it is 839 kilojoules per mole. So sometimes they can ask you the bond strength in calories. So we have a relationship between joules and calories. So it is nothing but 1 calorie is equals to 4.186 joules. So you just have to divide all these numbers with 4.186 and then you will get the bond strength in kilocalories per mole. So for example, if I want this bond strength of 356 kilojoules per mole in calories, means what I have to do, I have to divide this number with 4.186. So thank you for watching this video. If you like the video, please share and subscribe and like the button.